Hi everyone, we're going to be talking about logarithms. So this is an introduction to logarithms, and we're going to begin with logarithms in base 10. This is going to go in your interactive notebook on page 24. Let's begin by talking about the exponential function f of x equals 10 to the x. So we have base 10, and we want to find its inverse function, and we're going to denote that as f and then this -1 of x, so its inverse function. So here we graphed y equals 10 to the x. This is just a sketch, and here we have y equals x, and what we want to do is we want to graph the reflection across the y equals x line. And what I like to do is I actually like to flip the page around so the y equals x is vertical, and I just want to make sure it's a reflection across. And so I'm going to very carefully draw a line, and what I notice is that this point is going to be, this point right here is 0, 1, so this point right here is going to be 1, 0, which is the reversing the x and the y. And then notice that this graph never crosses the y-axis. So we have a vertical asymptote. So I'm going to flip it back. And here we have f inverse of x. Now the question is, what is f inverse of x? So let's take our equation for our function, y equals 10 to the x, and we're going to switch x and y, and we get x equals 10 to the y. Now how on earth are we supposed to isolate y? What we're going to do is we're going to use something called the logarithm with base 10 on both sides. So if we take the logarithm base 10 on both sides, we get y is equal to log base 10 of x. Okay? And I'll switch this around. So the inverse of 10 to the x is log base 10 of x. Okay? So this is just by definition. We define the logarithm as the inverse of the exponential function, 10 to the x. So example 1, we have, let's say 10 to the third is equal to 1,000. So therefore, we can write that the log base 10 of 1,000 is equal to 3. So for example, if we do 10 to the -1 equals 1/10, and what that means is log base 10 of 1/10 is equal to -1. So when you're taking the logarithm of a number, you want to figure out what the exponent is when the base is 10 in order to get this number right here. If no base is indicated, then we can assume that it means base 10. For example, log of 0.01 we can assume means log of base 10 of 0.01. And 0.01 we can write as 10 to the -2, and therefore the answer here would be -2, because 10 to the -2 is 0.01. We can generalize and say that log, and if we have 10 to a power x, then we're assuming that this is base 10, and so therefore this would simply be the exponent x. Okay, we're going to do a lot of examples next. So what you can do now is take out a sheet of loose leaf, and I'm going to do an example from each section that's assigned for homework. Okay, without a calculator, we're going to do number 1, and let's go ahead and do letter I. Without a calculator, we're going to find log of the cube root of 100. Well, again, since no base is indicated, I'm going to assume that it's base 10. And I'm going to rewrite this as 10 to a fractional exponent. And so therefore, this is going to be the cube root of, actually, let me go ahead and write it like this first. And then we know this is the index, this is the exponent. Old MacDonald had a farm, EI. So I want the E on the top and I on the bottom. So it's going to be log 10 of 2/3. And that's going to equal 2/3. Okay? All right, let's go ahead and take a look at number 2. Okay, so let's take a look at number 2, letter D. We have the log of 10 to the A over 10 to the B. And so I'm going to rewrite that as log of 10 to the A minus B. And therefore, this is just going to be the exponent since the base is 10. Okay. Number 3, we're going to use your calculator to write the following in the form of 10 to the x. So let's go ahead and do letter J, which is 0.00015. So I'm going to go ahead and find the log of 0.00015, and we need a calculator to do this. Control 10 to the x, and with the TI Inspire I have to enter the base, and here the number is 0.00015, and I press enter and I get negative 3.8239. Okay? Alright, let's take a look at number 4. That was letter J. Let's go to number 6. And we want to find x if. So I'm going to go ahead and write down letter G. So we have log x is equal to 4. Therefore, what we can do is we know that the base is 10. And we're going to rewrite that as 10 to the 4th is equal to x. So therefore, x is equal to 1,000. Okay? So just remember that the base is 10. The answer here is the exponent. And then x is the number that it's equal to. 10 to the 4th power is equal to this number right here, x. Now the next section, 4b, is very similar to the first section, 4a. The only difference is that the base can be a number other than 10. So we're going to dive straight into the exercise 4b and examples from each section. So for the first section, it says to write an equivalent exponential equation for. So if we're given log base 5 of 1 over square root of 5 equals negative 1/2, we're going to write down the equation. We're going to begin with the base 5. Okay, and then this, remember, is the exponent. And that's going to equal 1 over square root of 5. And that is a true statement, so that makes sense. Okay. Now, for number 2, it says write an equivalent logarithmic equation for. So now we're given an exponential equation. And so what we're going to do is we're going to write log. Now, what is the base here? Well, in this case, the base is 2. Okay. And then the exponent is going to be what the answer is. And therefore, the 1/2 is the number for which you're trying to figure out what the exponent is if the base is 2. So what number is 2 raised by to get 1/2? And that's 2 to the negative 1 equals 1/2. All right, number 3, we're going to take a look at letter R, and we just have to simplify for number 3. Oh, okay, so here we have log base 6 of 6 squared is 6. And so what I want to do is I want to write this expression here as with a base 6 and a rational exponent. So I'm going to write it as log base 6 of 6 times 6 to the 1/2. And I'm going to combine that as log base 6 of 6 to the 3/2. And that makes things really easy because I know that in this case I want to know what number is 6 to the 3/2 raised by. If the base is 6, well, the exponent is simply 3/2. Okay. All right. Number 4, we want to use your calculator to find. So we want to find the log base 10 of 74. So I'm going to go back to my calculator, and here you guys can see the whole screen here. So log is control 10 to the x, and this is going to be 10, and the number was 74. And what I want to do is, it doesn't tell me what to round to, so I'm going to round to 3 significant figures, 1.87. I'm going to write it out first though. 1.8692. And I'm going to round again to 1.87. Okay, this is what you need to do on the IB exam. All right, number 5D. The directions are to solve for x, and therefore we know that we're given a logarithmic equation. We want to find the equivalent exponential equation. The base is 2, the exponent is 3, and that's equal to x minus 6. Now this is a simple equation, and I get x is equal to 14. Okay? And in the last section here, number 6, we want to simplify. So in this case, this is very similar to what we did up here, number 3, except the base is unknown. It's so we have a variable x. So this is going to be log x to the 3/2. And if you get this number in a form where the base is the same as this base here, then it's very simple, and we just write down the exponent. Okay. All right. So hopefully that helped. And this is a review of logarithms from last year. Just let me know if you have any questions. You can email me or text me. All right. Thanks a lot. Bye.